Thank you for joining us. I'm Martha DeGrasse here for AGL, and today I'm joined by Jennifer Alvarez. She is CEO and co founder of Aurora Insight. Jennifer, thanks so much for making the time today.
Thanks, Martha.
I think it would be great for everyone if you could start off by giving us a little bit of an overview of Aurora Insight in case some people aren't familiar yet with the company.
Sure, be happy to. So, Aurora Insight provides data and analytics and insights to the wireless community. So, we collect radio frequency data, we measure it all over the world, and specifically in the United States. And we turn these measurements into analyses and insights that serve all across the wireless industry. And so as we do this, we're creating actionable information from raw radio frequency spectrum measurements. And this can help inform decision makers on how to invest in CapEx, how to have the best ROI on capital investments, how to optimize OpEx expenses, and just in general, strategies and decisions for business.
All right, fantastic. And give us a little bit of information about where you place these sensors. I think that part is really interesting.
Sure, we have a specialized sensor, and sensing the entire RF environment is quite challenging. So we've developed a specialized sensor and we deploy it in fixed locations. We have it driving around in cars, but also on aircraft and on a satellite. And we have two more satellites that are being launched early in 2021. So we have different tiers and regimes of spatial resolution for all of the different frequencies and technologies we collect.
Okay, awesome. Well, it's easy to think of a lot of ways that a lot of different companies could use the information. Let's talk specifically about the tower sector and tower owners. How can that group use this information?
So our information is especially valuable to tower owners and tower operators. We are able to collect this raw information about the wireless spectrum, the radio frequency environment, and distill it down to information that tower owners can put into action. So when we measure the radio frequency environment, we're measuring all technologies, all frequencies, all networks, all operators. But we can then map that information to towers. So we can actually locate individual transmitters. We can tell if that transmitter is on a tower and locate that tower. And then for the tower owner, what we can give them is not only the tenants, which they know for their own towers, but the tenants, so the operator of that network, what technologies are deployed per tower. Is it 3G, 4G, 5G? What frequency bands are in use? So is it mid-band, low band, or even millimeter wave? And from this type of information, the tower owner gets a much more comprehensive picture of what is actually on their tower. We even map a number of antennas per tower. So this gives the tower owner more complete information about their particular tower, but we can also do this for the competition. So a very powerful business intelligence tool. From this information, we can also map things like coverage and coverage gaps so tower owners know where they might want to invest in new infrastructure.
Excellent. And I'm sure that from this data, you're starting to see some trends in terms of what the biggest carriers are doing with their spectrum right now. T-Mobile obviously is doing a lot of amendment activity. Can you give us a little bit of an update on what you're seeing and how quickly you think some of that might translate into actual on-air deployments?
Yeah, as you mentioned, T-Mobile, they are rapidly deploying their 5G, and it's been predominantly in low band. And in fact, we even found low band 5G in Amarillo, Texas, which is a very small city in the panhandle of Texas. So they are deploying widely the low band, but what really is the sweet spot in 5G is what's called mid-band. And if you're familiar with the auctions that have been happening in 2020, those are really focused around this mid-band spectrum. Mid-band is so valuable because it has the best properties of propagation that low band does, yet higher bandwidths, not quite like millimeter wave and high band, but wider bandwidths and low band. So it's this sweet spot. Well, with the Sprint and T-Mobile merger, the Sprint 2.5 gigahertz mid-band spectrum all went to T-Mobile. And so deploying that as a mid-band asset is huge for T-Mobile. And we anticipate that the tower industry is going to see tremendous growth, thousands, tens of thousands of new towers required to proliferate this mid-band T-Mobile spectrum. On the other hand, you see AT&T deploying low band spectrum, doing that a lot. They had originally started out with millimeter wave high band. Now they're deploying low band. And of course, Verizon really stands to benefit from these auctions in 2020 because of the mid-band spectrum that they could acquire.
And do you see the T-Mobile deployment sort of putting the pressure on Verizon to go quickly once they get their C-band spectrum?
Absolutely, absolutely. So there are a lot of benefits, but also a lot of challenges with the millimeter wave high band spectrum that Verizon has been deploying. You've got low latencies and really wide bandwidth, which are very good attributes of 5G, but the signals don't travel very far and they have trouble penetrating any type of obstacles, buildings or foliage. So transitioning to a mid-band focus would still allow them to have the advantages of their millimeter wave installations, but supplement that with much better coverage, much better penetration. And since T-Mobile has really already made great strides in the low band and the mid band, Verizon has a bit of catching up to do in that regard.
I think so. Let's talk a little bit about rural America, if we could. I would think that the type of information that you generate would be really valuable for operators trying to understand where pockets are that need to be covered, and also perhaps for the FCC.
As I mentioned earlier, the modalities in which we collect data include driving around, having our sensors at fixed locations, and from general aviation aircraft. So from this technique where we can actually map mobile broadband coverage from the air, we're able to survey vast rural areas that normally you couldn't get any other data from other than only from theoretical models. And so what we're doing from the air is taking measurements of the radio frequency environment and being able to give a more accurate picture of what really is happening with spectrum being deployed and networks being deployed to serve the rural communities. And so this goes for areas where there are no roads, so you can't really drive around with test kits, and places where there aren't a lot of people, so there's not other forms of information coming from, say, crowdsourced applications.
Okay. So you probably do see a lot of large dead spots in the middle part of the country, right?
We do. There are vast areas that just have no cellular activity.
Okay. All right, good. And finally, let's talk about CBRS. I'm guessing that as that spectrum lights up in the middle of the country where there is no maritime naval radar, that a lot of that activity is attributed to new licensees or people using general authorized access. Are you starting to see that popping up?
We're seeing a lot more 3.5 gigahertz start popping up. Um, the 3.5 gigahertz is again that sweet spot of mid-band spectrum. It's also a little bit difficult though because there's the different tiers of access that are encumbered on that CBRS spectrum. But what we're seeing is that before the auction in July 2020 for the PALs, the general GAA, the general authorization access, was ongoing. And so we're collecting data and showing that there were activity, GAA type of activity, in the middle of the country from smaller regional operators. Then as the PALs were licensed, we're seeing more of those come online as these larger companies who have acquired hundreds and hundreds of CBRS licenses are starting to plan their networks with CBRS, but also smaller players, regional players, are employing it for smaller localized networks.
Okay, great. And I'm guessing that there are some private networks too, but you can't be just from the data you're seeing, you can't be sure who it is, but there's probably some that are close to big companies that might be starting a private network.
That's correct. Yeah.
Good. Okay, before we finish, I'd like to just ask you a little bit about your history in starting this company, why you founded this company, why this seemed like the right idea to you at this time.
Well, my background's very technical. I'm an electrical engineer by training, and throughout my career, I've always dealt with signals and communication systems, connectivity. And what I found in looking at the wireless industry, the commercial wireless industry, was that there was a lack of information. And so there are various data sources like databases. The FCC has their license database, the ASR for tower information, and other sources of data, but they're very much incomplete and oftentimes inaccurate. And so the community, the wireless ecosystem, is making huge decisions, billion-dollar decisions, based on incomplete, inaccurate information. And so what I knew from my technical experience is that if we measure the radio frequency environment and distill that into information that is accurate because it's based on measurements, then that would give the wireless ecosystem much better information to base their decisions on. And so that sold me. I'm all in and decided to start the business.
Well, good for you. Well, we're glad that you made time today to tell us about it. And I'm sure that we'll be hearing more from Aurora Insight in the future. Jennifer Alvarez, CEO and co founder of Aurora Insight. Thank you so much for your time.
Thanks, Martha. This was fun.